Okay, so this is the shortest unit. That said, being the shortest unit means that I'm going to ask more detailed stuff about what we have gone over. Okay, so you have less material to know. I expect that you know it to a greater depth. Okay, because there's that much less stuff. All right. So first thing we talked about in this unit, okay, was climate. Okay, and the things we need to understand are the components of climate and the factors that affect them. Okay, so components of climate: temperature, precipitation, light, wind, okay, and then the factors that affect it. That would be latitude, altitude, okay, proximity to mountains, proximity to the ocean, okay, all of that kind of stuff. In class, you did an activity to do with climatograms, but it also had a component of it that talked about the factors affecting climate. Okay, the climatogram essentially gave you some of the components of climate for each area, and then you had to figure out what factors were most important. You're going to be expected to do a very similar thing on your unit exam. Okay, I'm going to give you a location. Okay, you'll be familiar with it, or at least familiar enough with it for you to be able to figure it out. Okay, like I'll show you where in the world it is. Okay, and then I'm going to expect you to tell me, okay, what are the components of climate like in that area, likely, okay, and why, based on the factors that affect it. Okay, so it's going to be a bit of writing, right, but you're going to need to tell me the weather or the climate here is going to be like this. You know, the temperature will do this, the light will do this, the wind will do this, etc. And then, because these are the factors affecting the climate in this area, and here's how they do it, just like you were asked to do in your climate. Okay, but for a given location. So that's, you need to know those at, you know, a reasonable level. Okay, I mean, you obviously have to know what the components of climate are and what the factors are, so that you can write down the right ones, okay, for that particular question. Okay, could there be some multiple choice questions about this stuff as well? Yeah, there could be. There probably are. Okay, a few, you know, things about factors or a few things about components or whatever in the multiple choice as well. But that's kind of the big one, okay, in the written response. Okay, and then we talked about climatograms, right? And we already said that in the written response part of your unit exam, I'm going to give you a climatogram. You're going to have to match it with a biome and explain. Now, this is going to be a 5-mark question. Right? So I'm looking for more than Savannah because it's hot. Okay? Like, you write that, even if Savannah's right, okay, you're still going to get like 2 out of 5 if you're lucky. Okay? You need to, what I'm going to be looking for in there is evidence that you were able to interpret the climatogram. So your first little bit should probably say the climatogram says, you know, the temperature is doing this and the precipitation is doing this, meaning that place is likely like this. And then you would identify what biome it is and explain why those fit together. Right? That kind of stuff, that's what's going to get you the 5 marks. It's your depth of explanation. Okay? If all you write is what biome you think it is, that's worth 1 out of 5. You need to explain, okay, why those go together. Right? And then we talked about energy transfers in global systems. Okay, we talked about how energy is transferred. Okay, we talked about conduction, convection, and radiation. We also talked about the 3 fates of light when it strikes the Earth's surface. What were they? Absorbed, reflected, converted by photosynthesis. Okay, there's definitely going to be a question about the 3 fates of light. Right? It'll be a situational question. There'll be a picture involved with it. Okay, you're going to need to tell me some stuff about what happens with each of these, maybe the degree to which each of these occurs, and the degree to which light is absorbed or reflected is affected by albedo. Okay, probably an important word to include in there. Okay, when you're doing your explanation. Okay, so we definitely want to have those things. Now, again, remember that this is about a natural system. Okay? The picture will make that quite clear. I'm talking about a natural system. Don't add anything in that's not in the picture. Okay? If I'm showing you like a picture of a tropical rainforest, okay, don't talk about solar panels. Okay, they're not in the picture, they're not involved. Okay, they're not a global scale type of a process.
When you're talking about albedo, you said like when there's more snow on the ground, you tend to absorb less.
Right. Yeah, the albedo is the level of reflectivity. So the more reflective it is, the higher the albedo is. Okay, so there'll definitely be a question, okay, about the 3 fates, albedo, okay, things like that, right? Again, with a picture, situational. Okay. And then, okay, talking about the 3 methods, okay, the atmosphere is the most fluid, that's where wind occurs, wind is convection, okay, latent heat also moves in there. What moves the latent heat around? What's special? Jet stream, okay, so make sure you're including that. Okay, there's going to be a question about energy transfer at a global scale, where you're going to want to talk about the atmosphere, the lithosphere, and the hydrosphere, okay, the methods of heat transfer, the jet stream, okay, all of that kind of stuff, okay. Make sure you're explaining how they all work together, demonstrating your understanding. If you just say convection occurs and wind blows, I'm going to go, and so what's your answer? Okay. Yeah, so don't say stuff like that. Okay, you want to make sure you have a detailed answer. All right. Okay, and then there's going to be an application question to do with conduction, convection, and radiation. Okay? The day I taught that lesson, we talked about how like an insulated mug works or a cooler works, okay? Things like that. You're going to get a question similar to that situation. I'm going to ask you how you could either prevent heat transfer or harness heat transfer in a given situation, and that's where you need to demonstrate to me your knowledge of how convection works, how conduction works, and how radiation works. Okay, that's going to be a situational application type question. Okay, so when we were talking about those things, remember, I think this is a diagram of what an insulated wall looks like. It looks very similar to the one I drew the day I taught that. Okay, remember that insulation works because what does it prevent? Yeah, it prevents a convection current from being set up because the air is trapped. There's still air pockets, okay? Conduction can't occur through those, but since the air can't move, okay, you're not going to get any convection occurring through the wall, and that helps to insulate inside from outside, okay? Glass is a poor conductor of heat, okay, so it's not going to allow conduction to occur, plus there are all these tiny little fibers, right, so they don't really do a good job of that. And of course, the inside of your house, if you want to prevent radiation from occurring, what do you do with the inside? What color should you paint your walls? Yeah, lighter colors are going to do a better job of reflecting the heat back into the house. Darker colored walls are actually going to absorb a fair amount of the radiant heat in your house. So you'd want to do that. Sometimes in some places, they'll put that foil wrapped fiberglass in. You can see, you can buy it at like Home Depot. Okay, they're only about an inch thick or so, but they're foil size with fiberglass insulation in the middle. Okay, so it prevents radiation as well as the convection and conduction and all of that. Okay, you see it mostly used like for people that are living in a van down by the river. Okay, like the stealth camper people. So I fell down like this whole stealth camper like rabbit hole, and yeah, people how they like equip their vans and they live in their van. That's one of the tricks they use. Like, hey, that's like science applicable. And I was like, I'm such a nerd. Because not only did I fall down a rabbit hole about stealth camping in a van, but I found a way to catch it to science. This is the world I live in.
Isn't that called hopeless?
No, the vans are home.
Well,
You should see some of these, like they got them like all like tricked out, dude. And if I was gonna live in a van, it'd be that then. I don't want to live in a van. Okay. No, it'd be hard. I have kids. Yeah, wife and kids, so it'd be tough. Yeah. No. Okay. That's horrible. Okay. Wind patterns. Definitely going to be a question about wind patterns. Again, there's lots of diagrams on this test in the written response. Okay, so make sure you look at the diagram carefully so you understand. They're usually giving you some hints or telling you, hey, explain something that's in this diagram. Okay, so when we talked about prevailing winds, we talked about how they're the product of both convection and the Coriolis effect. Okay, so the air is actually moving up and down, north and south, but because the wind, or because the Earth, sorry, is spinning underneath that, it deflects it, makes it feel like it's coming from east or west. Okay, so make sure that you talk about those patterns of prevailing winds, the different convection currents at different latitudes, okay, things of that nature, where on Earth gets the most solar radiation, where it gets less. Okay, talk about the jet stream, okay, a little bit in there. This is like a really poor diagram of that. Right, so this is the convection current, so that would be hot air rising, and this would be cool air, okay? Well, it's still warm because it's at the equator, but coming in, okay? As the Earth spins underneath that, it makes it deflect like this, so it feels like it's coming from the east or northeast instead of straight out of the north. That's what it's actually doing, okay? At this latitude where we are, okay, that warm air is actually moving along the surface and cycling in a different way, okay? Kind of does this. Right, and then as the Earth spins underneath it, it deflects the wind that way. And then at the pole, you basically have like the vortex at the pole, okay, kind of doing this thing here, right? And so, boy, that's terrible. So spinning this way, and then when the Earth spins underneath that, it deflects it again as the east. Okay, so make sure you can explain kind of how that happens. Make sure you can explain the Coriolis effect, okay, because we spent a bit of time on that, so make sure you know how that goes. Okay, then specific heat capacity. There is one written response problem on specific heat capacity. Okay, you guys don't seem to have too much trouble with those kind of problems. Okay, so just make sure you know how to solve them and do a couple for practice. Okay. Also remember that specific heat capacity has a role to play in this factor that affects climate. Right? If that's something you're explaining in another question, it's not a bad idea to just drop specific heat capacity into that explanation. Okay? Proximity to the ocean affects climate because the ocean has a big heat capacity, etc. Okay? So solving an E equals MC delta T question. Then latent heat. Okay, so you're definitely going to get a heating curve question. Make sure that you can solve those problems. Okay, all of the necessary numbers are on the test. Okay, so 333 LF, okay, is on the test. The 2,260 LV is on the test. Okay, giving you those numbers. Any specific heat capacities you'll need are on the test. So ice, water, and steam are all on there, as well as any others you might need. Okay, they're all on the front page, so you don't have to memorize any of them. Okay, but expect you're going to have one of those. Okay, and then the last thing we talked about was biomes. Okay, and we said there'll be some multiple choice questions, picture, and a description. Don't just look at the picture. Okay, I can make a picture apply to a couple of different biomes if I get the right picture. Make sure you read the description as well. Okay, and then obviously the other one is the Climatograms. Okay, on the written response where you're identifying what biome you think it goes in. Okay, that's your test. Give you an idea here. Along. Okay, so we are looking at 25 multiple choice. Okay, and we talk about, like I said, there's biomes in there, there's heat transfer in there, the water cycle is in there. Okay, the atmosphere, hydrosphere, lithosphere, the fates of light are in there. Okay, some stuff about heat transfer, latent heat. Okay, if you just questions, not problems, just questions about it. Okay. There are no calculations. There are no calculations of any kind. And then in the written response, there are 9 questions for a total of 46 marks. Okay, and they're going to require you to do a bit of writing, a bit of explaining, and then there's obviously a couple of problems. Okay, not all of them, but many of them have a picture. Again, make sure you look at the picture, look at the details in the picture. Okay, things like what season it is in the picture, okay, or things like that could all be important. Right? Okay, so that is what you are looking at for your unit exam. Okay, any questions? Anything you want me to go over in more detail? Okay, then I will give you some time to work on that review sheet that I included, okay, the other day. I put it in Google Classroom the other day. It's the review sheet for this unit. Okay, this is some of the stuff that's on there. Okay, that's kind of the rest of it there. So you guys can work on that, or you can work on a little bit of stuff for your final exam. If you have questions, then just ask, and I'm happy to go over those with you. Okay, answer any questions. Obviously, so tomorrow we write your unit exam. Thursday, I'll very quickly go over it, review bio,